Hello everyone, I am Ümit. In this video, we will solve one problem in chapter 12. The system shown in the figure is in equilibrium. If the mass of the uniform rod of length 5d is 4 kilograms and that of the block is m as 2 kilograms, A. Find the tension in the cord, and B. Find the components of the force exerted by the wall on the rod. Because of the right triangle in the figure, the hypotenuse becomes square root of 34. Then sin theta becomes 3 over square root of 34. And cosine theta becomes 5 over square root of 34. To solve the problem, let us draw all the forces acting on the system. The gravitational force acting on block M is m times g. The gravitational force acting on the rod is capital M times g. Since the rod is uniform, the center of mass is in the middle. The tensional force on the rod due to the string is drawn like this. It can be decomposed onto x and y axis as follows. And the components of the force exerted by the wall on the rod is drawn like this. According to the following examples in the figure, torque with respect to the rotation axis passing through point O is defined by the formula tau O equals RO F perpendicular. As you see, F perpendicular is the component of the force perpendicular to the line of extension of position vector. The rotation in the first picture is counterclockwise, so we denote this rotation by a plus sign. In the second picture, the rotation is also positive. In the third one, it is negative, and in the final one, it is again positive. Okay, that's all about the definition of torque. Since the system is in equilibrium, so we say that first, the system is not rotating. Therefore, net torque about point O is 0. If we take the positive and negative directions as this, the torque due to the tensional force is 5d times Ty. And the torque due to block M is 2d times mg, which is negative. Finally, the torque due to the rod is negative 2.5d times capital mg. As you see, torques due to Fx and Fy are 0, because the application points are at point O. According to the figure, Ty is T times sin theta. Therefore, we obtain this equation. If we take these terms to the left-hand side, we obtain this equation. Here, these are cancelled, and if we divide both sides by 5 times sin theta, we obtain an expression for T as. Now we put the numerical values into the corresponding places. Therefore, the tension in the cord is found to be 53.334 newtons, or approximately 53.3 newtons. Because the system is in equilibrium, then it doesn't move. So, net force becomes 0 by the help of the Newton's second law. Net force along the x-axis becomes Fx minus Tx. Since Tx is T times cosine theta, then Fx becomes T cosine theta. We know T and cosine theta, so the x component of the force exerted by the wall on the rod becomes approximately 45.7 newtons. The net force along the y-axis is also 0, which is equal to Fy plus Ty minus mg minus capital Mg. Ty is T sin theta, So Fy becomes capital M plus mg minus t sine theta. We insert the numerical values into this equation. Therefore, we obtain this component as approximately 31.4 newtons. Okay, this is the end of the discussion of this problem. Thank you for your attention. See you in the next video.